Imagine sending a helicopter the size of a tissue box to Mars. Now, imagine it surviving 3 Martian years, over 1,000 days, in conditions so extreme they would obliterate most machines in a matter of weeks. That's the story of Ingenuity, a tiny 680-gram drone made from parts you might find in your own garage. It was never supposed to last. In fact, it was only designed for 5 flights over 30 days. But instead, it rewrote history. This is not just a tale of survival, it's a mission that defied expectations, redefined space exploration, and ended with a crash that taught us more than we ever thought possible. Ingenuity was born of skepticism. When NASA first approved its mission, even key leaders weren't convinced. It was an $80 million side project attached to the Perseverance rover, pocket change compared to most Mars missions. But the team behind it saw something more, a future where powered flight wasn't just a dream on Earth, but a reality on alien worlds. On February 18th, 2021, Perseverance landed in Jezero Crater, and attached to its belly was a humble but revolutionary companion, Ginny. The mission was clear: prove that flight is possible on Mars. With an atmosphere just 1% as dense as Earth's, Ginny had to spin her blades over 2,400 times per minute just to lift off the ground. She was fragile, experimental, a whisper of technology in a hostile, frozen world. But then came Sol 58. The blades spun. She lifted. Humanity flew on another planet. It was breathtaking, but it was also supposed to be the end. 5 flights. That was the plan. Check the box, declare success, and move on. Except Ginny kept going. NASA, stunned by her reliability, gave her a new mission: support the search for ancient life on Mars. Suddenly, this prototype became a scout, navigating dangerous terrain, finding safe routes for Perseverance, and doing what no other machine had ever done. But flying on Mars isn't like flying anywhere else. There's a 6-minute communication delay, which means every flight had to be pre-programmed and completely autonomous. Without GPS, Ginny relied on 2 cameras, one facing forward, one downward, analyzing rock patterns like an optical mouse to understand where she was. And then came Flight 6, her first venture beyond a mapped area. A glitch caused her to wobble violently mid-air. It could have been the end. But Ginny, resilient as ever, landed safely. A quick software patch, and she was back in the skies. Still, the red planet wasn't going to make it easy. As Martian winter approached, temperatures plummeted to 85 degrees. Sunlight, the only power source for Ginny's solar panels, dwindled. Dust storms raged, coating her panels, jamming her servos. JPL engineers watched nervously as Ginny's power dropped. Then, silence. No signal. Had the little helicopter finally succumbed? But the team refused to give up. They realized that Ginny's internal clock might have reset. She could still be alive, just listening at the wrong times. So they adjusted their signal schedule and pinged her again. And she answered. Against every odd, Ginny had survived a full power loss, freezing temperatures, and a system reboot. One component didn't make it: the inclinometer, essential for determining orientation before flight. Without it, Ginny was grounded, or so it seemed. The team turned to her smartphone roots. Her processor and sensors came from everyday phones. They repurposed the onboard IMU, Inertial Measurement Unit, a feature in all smartphones, to replace the inclinometer. It worked. She flew again. Ginny's journey wasn't just a triumph of engineering, it was a revolution in space hardware design. Using commercial off-the-shelf parts, components never designed for space, she proved that even in the face of cosmic radiation, low temperatures, and high-speed winds, inexpensive hardware can endure. This insight could change how we build space tech forever. Spring arrived. Sunlight returned. Ginny, battered but unbroken, was flying higher and faster than ever before. Her altitude increased from 10 meters to 24 meters. Her speed went from 2 meters per second to 10. She set records for speed, altitude, distance, pushing her limits with each flight. She wasn't just surviving, she was thriving. Then came Flight 71. The plan was simple: fly over a sand dune to meet Perseverance. But mid-flight, Ginny's navigation struggled. The camera couldn't find enough ground features to track her position. She landed hard, but miraculously survived. Still operational, she attempted one more cautious flight. Straight up, scan, straight down. But this time, she didn't make it. Flight 72 was her final bow. As she descended, the camera again lost visual references. Navigation errors stacked. The descent angle was too steep. The stress from the impact bent her rotor blades, and they snapped. The team watched in silence as the data confirmed. Ingenuity had crashed, but the wreckage told a deeper story. When investigators looked at the crash site, something was missing. The telltale scars of blades striking the ground. Instead, the evidence pointed to a phenomenon known as precession, a complex torque effect that occurs when spinning blades absorb a sudden force. It broke her blades at the exact stress points engineers had always feared. It was a physics lesson, a posthumous gift from a machine that never stopped teaching. And even in her final state, Ingenuity had more to give. She didn't die completely. Her core systems still worked. She continued capturing images, monitoring temperatures, acting as an unplanned weather station, a silent sentinel on the Martian surface, still contributing to science even after her final flight. Ingenuity's legacy doesn't end with her fall. She gave rise to Chopper, the next-generation Martian helicopter. Bigger, stronger, more capable. With 6 rotors, onboard scientific payloads, and direct communication with orbiters, Chopper won't need to trail a rover. It will be free, flying anywhere on Mars. It's a vision of the future where aerial exploration becomes routine on other worlds, where Martian airports and skyways are no longer just science fiction. This once-dismissed tech demo rewrote what we thought was possible. The same way the Wright brothers redefined earthbound aviation, Ginny redefined interplanetary flight. It's no coincidence that attached to her frame is a small piece of the original Wright Flyer, the first powered aircraft on Earth, now resting with the first powered aircraft on another world. So if someone tells you that your dream is too crazy, too risky, too improbable, remember Ginny. She wasn't supposed to fly, but she did. And she didn't just